And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and we're looking at the sun here, the closest star in 304 angstroms, which is the ultraviolet radiation from ionized helium at very high temperatures. We've got two major sunspot groups. This one up here, and this new one having just risen down here in the southeast. And we never saw the geomagnetic unrest forecasted from the glancing blow coronal mass ejection that we saw a few days ago. Here's another wavelength from the Solar Dynamics Observatory. This is 171 angstroms ionized iron. Great views of those two active sunspot groups. More close-up analysis of those at the end of the video. Here's another one of the ionized states of iron. It's 193 angstroms. And we've got some significant coronal holes rotating in here, one right ahead of this new sunspot group, right down here. A more diffuse one up here, near the solar equator. And here's a diagram of the solar system if you're wondering where stuff is in the solar system. Here's where it is now. We'll advance this 1 week. And it looks like we've got a new moon coming in about 1 week. There's where things will be at that point. Here's a star chart. And if you're up before dawn, you may see the moon just south of the ecliptic if you're in the northern hemisphere. So there's the location of stars and constellations at this point. If you want to make your own star chart, check out in-the-sky.org. Put in your location. This yellow line is the ecliptic, the path the sun will take across the sky. The 10.7 centimeter radio flux now at 75 solar flux units. And if you're not familiar with what that is, it's a 2800 megahertz radio emission from the upper chromosphere and the lower corona that the sun is always outputting, and it's the most proportional data set that we have to sunspot number. In other words, it's a very important solar proxy for solar activity. So here's the black line here. You can see this black line is the 10.7 centimeter radio flux, and you can see how proportional it is to this red line, the sunspot number, which is the main feature used to describe how active the sun is at a given point in time. Again, we have not seen the geomagnetic unrest at all come from the coronal mass ejection. We saw a very weak strike yesterday. It was a little more short-lived than we even expected. So it was a glancing blow indeed, a very weak glancing blow. I think it's probably complete now. I don't expect to see any additional pulses from this set of coronal mass ejections. Next, let's check out global seismicity. I like volcanodiscovery.com's 90-day bar chart showing the major earthquakes here. And you can also sort this way onto a map. Here are the 3+ magnitude quakes. Here are the 4+ magnitude quakes. And there are the couple of 5 magnitude quakes that we saw in the past 24 hours. Let's check the list on USGS's website, the United States Geologic Survey. At least one deep quake coming in the past 24 hours, this 4.0 at Afghanistan. Also a deep quake at Bolivia, one of the largest of the past 24. This 5.3 magnitude quake was at a depth of over 200 kilometers. Also, Indonesia saw a deep quake. A 4.4 magnitude at 190 kilometers. Here's a 4.6 at the Philippines, also at depth. Greece saw a 4.7. So some seismicity there around the Mediterranean. No major quakes over the past 24 hours. And Volcano Discovery's Volcanoes Today page is back up. Cheers to volcanodiscovery.com. Let's see what volcanoes are erupting. Subanose-jima in the Ryukyu Islands. While volcanic ash is not identifiable in the satellite imagery, Please do not decide to build a campsite on the lower slopes. It could be unfortunate. Also, Semeru on East Java. Looks like an uptick there at Semeru, producing a 14,000-foot ash plume as it explodes. Sangay in Ecuador also exploding. 22,000-foot ash plume there. Revenador in Ecuador also mildly exploding. I don't know what's mild about a volcanic explosion, but there it is. Sporadic emissions of volcanic ash. No flight level listed for that. Sabancaya exploding. A little bit of an uptick there. It's producing a 27,000-foot plume of ash. Nevados de Chilean, 14,000-foot ash plume as it explodes. And Nyiragongo continues to explode near the capital city of Congo, Goma. It's now producing an 18,000-foot ash plume. So continued eruptions happening there. Also, Stromboli's been erupting. If you weren't aware, we covered it on a previous video. A great reminder to not pole vault the caldera. Of all the things you could do, pole vaulting the caldera, it would be one of the very unfortunate ideas to come up with, especially on an active volcano. So please don't do so. And this public service message brought to you by smAshomash.com, because a lot of people are stupid. Next, the GOES X-ray flux here over the past 3 days, and there's a solar flare happening as we make the video here. We'll be interested to see how high of a degree of a solar flare this becomes here, how significant. It's already into the B class and climbing while we made the video. No major flares over the past 24 hours, although there was a C class flare yesterday at the low level of the C range. No spikes in the proton flux, and no surprise there, as no major coronal mass ejections have been heading our way. And here's the GOES magnetometer over the past 3 days. We did see a heliospheric current sheet polarity boundary crossing. Let's take a look at that. And you can see Earth is, well, maybe you can't see, but Earth is now in a South Pole-oriented current sheet for the foreseeable future. That current sheet shown here in red, charged up by the South Pole. So there's the South Pole current sheet in red there. Earth having left the North Pole current sheet. And now the planet's potential field surface source line is in South Pole oriented current sheet territory. Here's another view of the same data from the line of sight perspective instead of the top view as we showed in the last frame. A great three-dimensional view there. And next we'll show the sun's B field and coronal holes. It's the line of sight coronal hole plot. And the sun's B field is shown here in blue. And you can see a South Pole-oriented coronal hole here stretching up toward the equator on the east. So ahead of that new sunspot, a coronal hole. We'll be keeping an eye on that, as it's been emitting some ions, to say the least. Coronal holes are low-pressure systems on the surface of the sun, and the low-pressure system is so low that it's blasting out protons all the way through the solar system to the point where they'll reach the Earth's geospace. Next, looking at the sunspot groups here, the magnetogram analysis and detected filaments. There are still significant filaments, especially in the southeast. There is significant possibility for strong solar flares, and well, one's going on as we make the video. We'll be interested to see where that leads. Anyway, there's the detected filaments and detected sunspot groups. So two groups now, Sunspot 2827 and Sunspot 2829, will certainly get a name today. It's quite significant. We'll show you the high-res imagery of that later in the video. KP index currently at 1, and if you're a new viewer, the KP index is a measurement of global geomagnetism. Before we look at more geomagnetism, here's the real-time solar wind data, which is pretty uneventful over the past 24 hours. Current solar wind density, 9.81 protons per cubic centimeter. Solar wind speed, very low, under 300 kilometers per second, listed at 292 kilometers a second. Extremely low solar wind speed. Let's take a look at a visualization of some of this data. It's the magnetohydrodynamic pressure, shown in nanopascals. It's the geospace magnetosphere movie should be 4 hours of data. And most of the pressure here is a result of the solar wind density, not the speed, again, which is extremely low. We don't see it drop below 300 kilometers per second that often. Next, ground magnetic perturbations. Changes to Earth's B field shown in nanotesla as opposed to nanopascal. Nanopascals are magnetohydrodynamic pressure. Nanotesla is the magnetic flux itself. So these are changes to the Earth's B field. And since that refresh, we're going to let that play through as we don't edit the videos in order to get them out to the public in as timely a fashion as possible. So since we're living through a geomagnetic excursion, Earth has 2 north poles, one over Canada, one over Siberia, and the south pole is someplace down here, south of Australia, having left the Antarctic continent entirely. No major perturbations to that. By the way, if you don't follow us on Twitch, maybe download the app. We do regularly stream live, which we'll be doing momentarily for our cosmology segment, and then later for our meteorology segment, which will be separate videos today. Thanks to our YouTube subscribers. And if you're new to the channel, please don't forget to press subscribe, check out the other videos in our playlists and so on. We produce quite a bit of content on the channel. And we're also counting down to the solstice. We will be streaming live at that moment, 11:32 p.m. and 9 seconds. That's Eastern Daylight Time. Join us for our live streams. We'll be streaming in at least 2 locations, including YouTube and Twitch. And you're all invited to visit our own website as well, smashomash.com, smashomash.org. We'll redirect you. We've got some of our smashomash.org Presents the Sun videos right there on the homepage, as well as links to our social media accounts and our shops and our forum. Today's featured product, which you can find if you click on smAsho merch, is the Google Bias shirt. So here's our red bubble shop. And one of the products there is the Google Bias shirt. I'm currently wearing a Google Bias shirt. Here it is. Hopefully you'll be able to see it. Yes. And Google does not refute the fact that Google is biased, since Google will take money to get your own website or whatever listed higher on the search results. If you're still using Google as a verb, please enter into the 21st century and stop using Google as a verb, unless it means to obtain biased search results by searching for someone or something on the World Wide Web. To use it in a sentence, I Googled it, and now I know less about it. Welcome to the Neo-Renaissance, by the way, folks. Congratulations on finding our videos. Again, links are available at smashomash.com and redirects from smashomash.org. And next, I'd like to thank our patrons, a true source of funding for the content. Please consider becoming a patron if you would like the most early alerts of anybody in the world. Also, we dumped a bunch of ringtones yesterday and other sounds for your smartphone. Perhaps you'll enjoy those. Let us know in the comments if you're a patron and you like those, or you dislike those, or you're using them for your phone. I don't like stock ringtones, and so I make custom ones. Thanks again, patrons. Patreon.com/smashomash for all kinds of behind-the-scenes science articles we don't share with anybody else, as well as all kinds of the earliest alerts that we send to anybody. Patrons are listed in order of lifetime total contribution. Next, looking at electrons, which have the ability to charge up satellites and cause communications failures. We don't see any charging hazards right now. Here's a 1-year chart of the electron flux. The Earth is surrounded by electrons, and they give us insight into what is going on with the magnetic fields of the planet. Here's a 3-day chart of the electron flux. And we've got missing data across the board here for a small period of time yesterday. And it's on various instruments here, missing data. So, in any case, the electron flux is in a little higher range here than we saw in the past couple of days. Here's the forecast model for the electron flux. No real argument there. The green boxes are the forecast, the yellow diamonds are the observation. And here's a visualization of the total air column, the total electron content forecast. It'll show you where GPS errors are most likely. And the closer to red you see these colors get, the larger your GPS error is likely to be. And we see some anomalous electron belts here once again over places like the Central Atlantic Ocean, West Africa, and even Mexico and the Caribbean, seeing some high-density regions of electrons up overhead at nighttime, when most GPS errors do not occur. Here's a diagram of Earth's Van Allen belts. We show this for reference each day. Feel free to pause the video. Distances are in miles. Here are other distances shown in kilometers, showing you things like the temperature of the thermosphere, the penetration of electromagnetic radiation into the atmospheric layers, and over here the F layer at about 300 kilometers, the F ionosphere layer, which is what we'll show next. And this is actually 2 days of data. We see a very low vibrational ionosphere at the end of the video. We'll stop it on the last frame here after it plays through. Here's the latest image from 8:45 Universal Time, and we see a very homogeneous ionosphere here. So this is quite anomalous here, a very low vibrational frequency ionosphere, only making it up to mainly about 8 megahertz there. So a highly discharged ionosphere. Ionosphere looking weak. And let's close things out on the daily space weather with some bonus features. The ground-based solar observatory at El Teide, Spain. Here's an animation of what's been seen there. I would note there are significant filaments down here, some down here, and some up here. So we could see coronal mass ejections, we could see significant solar flares. And I'm not sure where the flaring came from when we did the video. We'll have to cover that at a later time. Here's some more imagery of the closest star. It's the latest high-res intensitygram and the latest high-res magnetogram. So first, Sunspot 2827. There it is. It looks like the main umbra has degraded a little bit. It's not looking as dark as it was. And here it is in colorized magnetogram. Great views of that. It is still a beta class. It still does harbor the type of magnetic fields for significant solar flares. And here is Sunspot 2829. It's looking quite well defined. Anyway, there it is in the intensitygram. And there are the fields. It is beta class. If I had to guess, I would say that's probably where the solar flare that we were seeing came from. And here are some more close-up images of El Sol. This is 131 angstroms, the northern hemisphere. Great view of Sunspot 2827, as it does appear to be degrading a little bit here. Here's the rising of Sunspot 2829 in this same wavelength. And 131 angstroms is another one of the ionized states of iron. Great view of that and the Earth scale there. Here's 193 angstroms. Great view of this coronal hole, which is ahead of Sunspot 2829. And we'll close things out at 94 angstroms. Another ionized state of iron. And thanks once again for tuning in to the Daily Space Weather. Welcome to the Neo Renaissance. Don't forget to press like and subscribe if you enjoy the content. Don't forget to tell your friends, foes, science noobs, and science pros about the channel. And we'll see you next time. In the meantime, may that solar wind be at your back.